more on processing. Same with RGB. The longer the sub-exposures, the more of them, the lower the noise is going to be in the stacked frame. And typically, the hydrogen alpha is a lot more a lot stronger than the S2 or the O3. So you'll either need to stretch it out to look similar, the histogram similar, when you're processing, or shoot more data in those two channels to balance them out. Otherwise, you'll have overwhelming hydrogen alpha. So I don't know if you've seen on forums, people have like a green image, like all green, because they didn't balance out the hydrogen alpha with the other two channels and whatnot. And it can be done in post as well. Most of the time I'll shoot the same exposure times and balance them out when I'm processing. But it's just something to keep in mind when you're mapping everything to balance the histogram.
So Lonnie, you'll pre-stretch the S2 and O3 before?
Well, I'll process each channel individually.
Oh, okay. See, I have not done that yet. Okay.
And as opposed to stacking, aligning, and stacking them all together, like you might do with RGB, I'll stack all the HA, S2, whatnot,
Right.
align them together, but then process each separately before I combine them, so I can balance them.
But try to get them equal on the histogram.
Correct.
You remember the bars thing I tried out? Yeah. It's the same way. That's what I do there. I do each one individually.
Yeah.
You know, I mean, it's just, they're videos.
Yeah.
You stack all of them, you process them just like as if you were doing it with a bare matrix camera.
Right, because blue or S2 is most affected by atmosphere, right? So sometimes that has to be really pushed out.
Yeah, and I know some people that'll shoot exponentially longer for the S2 and O3 than they do the hydrogen alpha to balance it out when they're shooting, so they can just combine them when they're stacking.
Okay.
But I personally prefer to just process them all separately.
Okay.
Now, what about your stars? You know, there's a lot of debate that, I don't know how it adds up, but like, for example, the famous Pillars of Creation, they're all magenta.
Yes.
Okay. Do you, I'm assuming that you see all those magenta colors and all the variety of magenta colors in the stars. Would you like, is there a way that you can assign the different degrees of that color to, you know, a taste of false colors? In other words, that not all of them are magenta. Say that the ones that are not as magenta, you will make those green, or excuse me, blue, and then the ones that are in between green and the ones that are magenta. Do you do that? Is what I'm thinking. Because I mean, I see all these pictures and I don't see this.
It's because the emission lines, the Hubble team doesn't bother with it. They'll just stack as great, so the stars will look magenta or they'll have halos and whatnot. Because they're more concerned with the data in the nebulas and the stars. And the emission lines don't line up perfectly with red, green, and blue, so you don't have the actual star colors in there with the narrowband. So a lot of times, if I'm just shooting narrowband, I'll completely desaturate the stars, just have them white. So I don't have magenta or green or however the palette ends up being. Or I'll use RGB for just the star color. And so I'll just pull RGB stars off, like shoot like one DSLR frame to get RGB stars, stack them over top for the star color.
Mm-hmm. Do you ever see bloating with particular channel, narrowband channel, more than? That's what an issue I was having. I
do an O3, but I think if my system doesn't like the blue channel at all, and it does the same thing with the blue, green, and the O3.
Okay.
And it blows.
So you say your system, you mean your chip?
It's actually my scope.
Oh,
so
really?
I've tried multiple cameras.
So it doesn't want to focus?
My scope doesn't like to focus the blue
because
channel.
This is an elementary question, I'm sure. I'm very interested in this, but don't have much experience. Do I understand that you use different color filters with different exposure times on the same film, one after the other, or take separate films with different filters?
I don't use film.
Them?
I'll use a CCD digital camera. I don't use film. CCD digital camera.
Mono though, right?
Oh,
yeah, and it's mono camera.
However,
so
it's recorded electronically or analog, whatever.
Yeah.
Right.
So it's all monochrome. So I'll have a particular filter in there, and then shoot it and save that file, then do the next filter. And once you can combine them into the various colors to make the color image.
And she puts it in what's called a filter wheel, so she collects data and then she rotates it around to the next filter, so there's no.
Yeah, so it's not writing over
You don't
top
have
of
to
each
pull the
other.
optical train apart.
Yeah,
Yeah.
it's saving them all as different files, and then you combine them on the computer to do the RGB. So,
Thank you.
and as I was saying, you use RGB data combined with narrowband data to pull out emission regions of broadband targets. Like this one, I use hydrogen alpha to enhance what is mostly a broadband target, and I did mostly RGB, but I shot hydrogen alpha with it as well. Some will have more blue and O3, so you can use that and roll that in with the blue. Or like I said, you can use just the star colors and all your narrowband data and have like the Hubble palette, but have natural star colors.
Have you ever done any one filter on a reflection nebula?
Pardon?
Have you ever done any like one type of narrowband filter on a reflection nebula?
I have,
And it didn't turn out great, or was
it just doesn't have as much because,
there was no point?
yeah, I mean, like I'll use it to supplement, but not just for narrowband.
Well, of course, yeah.
But yeah, so like this one, I mean, I use hydrogen alpha on it, though
That you
it's,
mentioned, yeah.
yeah, so but it's,
It's just weird. It's like, this is me, I don't know anything about physics, nature of life, or whatever. I just know what works. And so, I mean, that's just the way I go with, going, with the flow. And it's like, these things, emission nebulas, they're ionized, right? So it's like the light coming from the stars are what's doing this, right? So I would think that the stars, because they show up in every one of these narrowband filters, that the star light would also, cast their glow on anything that's solid, in other words, dust, and
You're not
so you would see
getting
that.
reflection, you're getting emission. It's stimulating the atom, and the atom's re-radiating the light in a different color.
Yeah, they're photons.
It's being absorbed
It's being
and
absorbed.
re-radiated.
Not a wavelength. They're cascading down, there's certain lines they can release that
The
energy.
Pleiades constellation is a reflection nebula like a mirror.
Yeah.
Light hits it and bounces off.
Yeah, but
That is
what's the light?
emission.
But where is the light coming from
The stars.
to start? Well, what's causing that
An
light?
electron moves from one energy state to another.
Okay, yeah.
Right, it's one, and it's always the same in the periodic table of the elements. It won't vary.
A hydrogen atom absorbs blue, green, red, yellow, all those, but it only radiates red.
Okay, so what's bouncing back then?
Nothing is. It's
Only a
absorbing.
portion of it,
So
it's
when
like
an
reflecting.
electron,
Well,
It's
if a
absorbing the
reflection
light and
nebula,
radiating
something
it.
bouncing
Well,
back. What is it?
It's absorbing the light as energy, and it's re-radiating that energy at a different wavelength.
Well,
No, at a reflection. it's
Michael, correct me if I'm wrong, an electron drops down to another state.
yes.
When it drops down to another state, a photon
But you're
has to be
saying
emitted
there-
in order to balance
What-
the,
Right, so-
yeah,
what-
at a wavelength. At a
Wait a
wavelength.
minute, what Chris is saying, Chris
Well,
is
I'm
asking
just
about
asking
reflection.
If it's a light that's bouncing back, why can't you have an narrowband
Right,
filter that can capture that radiating light from a reflection nebula?
well, because it's wide band.
It's
Right.
wide band.
Right.
There,
But why
You don't
does
need
but
something
if
that's
it's
small
blue,
enough.
then all would have to do is do a blue
Right.
channel, and that's
Right.
it, right? 'Cause
I mean, that's
what
the
most
part I
reflections
don't
are.
get, is how do the stars come through? Why aren't all the stars red? Or
They're
green,
brighter.
or blue?
what you mean with the filters?
Yeah.
It's brighter.
'Cause they,
I'm just
I
asking.
don't
this.
know.
See, that's
Like-
the thing
I know
but,
they get cut down because of their absorption lines or where you're
Right.
going
Like
out,
a
but
reflection nebula.
so you're
Like-
getting
I'm
a
sure if
lot
you
more
got,
light.
I'm sure if you got narrower enough that it would
Right.
cut them out.
Like the trapezium, it heats everything, right?
Right.
Okay, makes an emission nebula,
Yeah.
right?
Mhm.
So does that mean that it doesn't heat dust?
What you're saying
And
is
if
there
it
should be
heats dust, then all
reflected
you have to
light.
do is do an infrared.
There
light.
is reflected light mixed in, but it's kind of like you can't see a sunspot on the sun. Okay, but if you look at it, the sunspot's black.
Yeah,
But if you look at it with your eye, you can't see it because you're overwhelmed by the light
or it's
around you.
bleached out, yeah.
Right, that's what's happening here. The emission light is so much stronger than the reflected light, you don't see it.
That's
It
correct.
overwhelms it.
That's correct.
But in this case, it's filtered out. right?
I'm just wondering
Because
if there's like a-
reflected light is wideband.
Right.
Okay,
so
yeah, I'm
filters-
sorry if I'm being an ass here, but
No,
what
no.
I'm getting at is just like, so, the blue spectrum,
Right.
for like Pleiades, for example, right? We know that, like, moonlight, if we were to just capture, blue light, a broadband filter of blue light, if we were in, like, out of the Outer Banks, if the moon's up, it's still gonna mess it up despite there's no light pollution out there, right? Okay, so if that's the case, which part of the blue broadband area is most affected by moonlight? And if you figure that out, you just make a filter that's not in that
Well, what
section
you
of
would
broadband
have to
blue.
do is
And
measure
then
the
when you
moon.
do that, then you
Measure
get
the
reflection
waves,
nebula image. So
Right.
why hasn't anybody done that?
No.
Right, because
It's so
it's
broad.
expensive as hell.
Is it broad?
Well,
Right?
yeah.
It's so broad, you
Who-
can't maintain contrast enhancement because you would have such a wide filter that your contamination from background light will be comparable. So the reason you win here is that these lines, especially like the optional 3,
Very
are
narrow.
20 angstroms wide.
Yeah.
So you're gonna chop out such a notch in wavelength.
Okay, so here, I'm gonna be
You get
difficult,
the entire
I'm gonna
line.
be
but
You
difficult
still
some
get
more,
some,
so
but it just cuts out so much.
Yeah,
if you have like an infrared filter, because that dust is getting heated somewhere, right?
You mean like
And an infrared
all-pass
camera?
filter? It's like
An infrared.
850 nanometers.
Well, H alpha is just above infrared.
Yeah, so if you do an infrared filter, because that dust is getting heated, can you pick up reflection then?
If you mean thermally, then we're talking about 10 microns, right? That's the thermal temperature. That's why if you think of mountains in and out of space. You'd be looking for dust at, let's say, 1,000 nanometers. You're talking about dust at 300 degrees Kelvin, not the typical temperature you find dust at.
So that would be hard to resolve.
So for those of us who are dumb and didn't go to college.
From the
it's
ground
always
base,
the
yeah.
Last 5 minutes.
I get what you're,
Which is me.
I get what you're saying. The problem is what you're talking about is
It's way too much light.
It's wider.
The light is spread too far across the spectrum.
exactly.
Okay.
Exactly. You know how when they do a what do you call it, a spectrograph,
Yeah.
and you get those
You
lines,
get those
real
individual
bright
lines of whatever
lines.
substances
That's
are
what these
radiating
filters
light.
are doing, is letting
When-
in that bright
Or
light.
When you
emitting
look
light.
at a planetary nebula, you pretty much see two lines in the spectrum,
It's mostly
O3 and HA.
Yeah.
Yep.
All the light you see is just in those small areas, and that's what you're picking up. So if you image with just those, you're getting all the light. Versus if it was beyond that cutoff, what you could see visually would be more than what you could pick up from just those lines.
But I would assume when you're photographing, let's say you're doing H alpha, and you've got carbon stars in your field, obviously that's gonna let more light through than the white stars in the field or the blue lights.
Mhm. I haven't done like star measuring to,
Yeah.
I haven't gotten that deep. to say,
But
oh,
you
this
are
is this-
still getting all
But yes.
three wavelengths,
You
so
are,
it's
you
basically
are.
making one.
Right,
Yeah. See, all the stars in the field radiate all three of those colors. And so when you take three colors and put them on top of each other, what do you get? White.
Yeah, of course, yeah.
So
So,
we're not sampling blue with this filter set.
well, yeah.
Barely.
Well, they all, I imagine they all have
Turquoise,
varying
something like
amounts
that.
of that.
Blue.
Exactly,
So
based
they'll
on
get
their
different
type.
colors.
Right, carbon stars are very red.
Yeah.
Yeah.
this is kind of a pictorial example of the last
Sorry,
bit
I
of
mean-
time.
Or wouldn't that be?
No, it's fine.
Screen.
So, top left is, this is all the same target, same orientation, everything. Top left is RGB only. And you can see how much you can see there and what the stars look like. The top right is hydrogen alpha only. The bottom left is using the hydrogen alpha for the data and the color from the RGB. So you end up with the reds and the star colors, but you still have the hydrogen alpha data. And then the bottom right is all narrowband. It's S2, HA, and O3. You can see here, especially the comparison between the RGB and the narrowband, the extra depth and contrast you get, as opposed to just seeing this all red. You can see all the different ionizations in there and see blues and whatnot. It helps break out the running chicken a bit more even, because you get the blue behind it and it's offset with the hydrogen alpha as well, so it stands out.
Now, is that because your exposure times are so much longer that you've got more signal?
For what, compared to the RGB, or?
Yeah, compared,
It's just letting different lights through
okay.
as well, and focusing, it's
I
focusing.
mean, there's so
on-
much
I mean,
more
it is-
contrast in bottom right than
It
top
is, yeah, I mean, part of it's that, but even more so is just the amount of focusing of the light and how it's stretched.
I mean, you
and
can
mapped
see
out.
a huge difference in the bloom of the star.
Yeah,
I mean,
well,
that,
yeah,
you're seeing
because the
a lot of
narrowband's gonna
detail
cut
that
down the
star
light of
washes
the
out.
star through as well, yeah.
Now, you did that Hubble palette?
Yeah, that
Yeah,
bottom right
that, it
was on the
looks,
palette.
that's what I was thinking.
Have you ever like added, I've never seen you do this either, maybe it's pointless as well. Have you ever done a Luminous channel with the other two?
With
Sulfur and
solely
oxygen.
sulfur and oxygen?
My head's in the way?
I'll use like a
Have you ever
combination,
tried
of
it
like,
because it looks-
I couldn't
I'll
see
add
HST.
in like sulfur and oxygen to the hydrogen alpha and have like a master narrowband luminance. I'll do that occasionally. But I never just use the sulfur at all. There's generally not as much data. Hydrogen alpha is normally predominantly strong, which is what I'll typically
So you've
use.
never done it before?
I'm sure
I just didn't have enough find someone to ask.
Can you give us an idea of how long it took you to?
This one is not mine. I got permission from
Oh.
a friend of mine to use this.
Any idea of the length?
I can pull it up. I don't remember. What it
Days,
said. I think
weeks.
the compilation of the Hubble palette was 18 hours of data.
Wow, okay.
I want to
That's
say.
exposure time?
Yes, ma'am.
Not all in one
Add it
night.
up, add it up.
Yeah.
Not all in one night.
I've got a few other examples too. The rest are mine, so I can add. Well, this is just a close up of that.
Back in another,
Yeah.
the RGB is typically when you use the camera that's used to do that.
We're moving.
Have you removed
We're not
any
sitting
of the
still,
kind
no, that's
of
not
like
sitting still.
IR filters
Huh?
in the camera?
I use the same CCD camera for all of it. I've got Luminance, RGB, Hydrogen Alpha, O3, and S2 all in the filter wheel. And so
Okay.
it's all,
Oh, so it's, so, okay,
this is all
so,
CCD.
I'm thinking, sorry.
Sorry, not DSLR. So.
Can you do it with DSLR if you've got a full spectrum DSLR?
Yeah, if you've got clip-in filters or whatnot, yeah.
Right.
You'll lose some with the bare filter.
Yeah.
Yeah, but,
I
yeah,
haven't
okay.
bothered to scrape that off yet.
This is just a
I
close-up
love
to show
watching your
the
videos.
depth of this one compared to the RGB, so.
You know what that is?
Yeah, actually, you can't. remove the
Yeah,
bare
IC
lens.
2944, running chicken calculator.
No, it's part of the chip that has, like, it has lenses.
Well, it looks like.
I bet you this mic.
Yeah, it actually focuses.
There's just a few other examples,
You're
these are all
kidding.
mine. Most galaxies, you're not gonna get much out of
I
narrowband.
thought it was part of it.
A few of them you'll get some hydrogen alpha out of, which M81 is one of them,
Life's
and all the pink globules are all hydrogen alpha, so shooting that hydrogen alpha, all I see is that. You'll see the stars and none of the galaxy lines, you just see these
I've never seen
globules.
anybody post a mono of that, of a H alpha channel of a galaxy.
I can send it, I'll post it, I'll find it, I've got it somewhere in my files.
I've always been
When I
curious to see
stacked
what it
this,
looks
this was
like.
a while ago. But yeah,
It's not that
'cause,
great.
all you see are those globules.
So,
Do you remember?
so Ani, I've got a decent shot of M81.
Mhm.
What would if I go back to that, it doesn't look like there's much H alpha in there. What would you use?
There's not, I mean, H alpha's the only one that's got in there.
Okay, because
And
I would
it's
like
not
to
a
use
lot.
that
It'll
in,
just enhance these.
I'd like to replace the
Yeah,
luminance
it'll
channel
just
with the
enhance
H
these
alpha.
levels. No,
Okay.
you don't, for most galaxies, you're not gonna use
You're not, yeah,
narrowband.
okay.
Some will have a little O3, some will have some HA.
Think of it like imaging a star, right? A star is broadband.
Right.
So, a galaxy is just a collection of
It's-
stars.
Yeah,
So
so
it's all
they'll have a
broken.
few, like, most galaxies have.
So I'll just
some
pick up
bits.
those little snippets in
Yeah,
there.
basically what you see there is like the pink purple,
Yeah.
those are the hydrogen alpha bits. So just shooting this hydrogen alpha, that's basically all you see on the frame, that makes
Mhm.
sense. So,
Mike, you can also, like M82, for example, you can pick up some of the jet, there's some other
Yeah.
features sometimes, but, yeah, that's all the H2 region for the star formation happening. So something like elliptical that has no star formation, it's useless.
Well, I was thinking some of the dust trails, if they're,
Which is why galaxies weren't on the list of ideal
Well,
targets, is
they're basically
you
designed
get very
like
little
hydrogen, they can design
advantage
stars.
from using
Right.
narrowband on
So
them
something
at all.
that doesn't have young stars is not going to
Is
be.
it safe
Okay.
to say that narrowband is mostly used for nebula?
Correct. Top right is bicolor, it was hydrogen alpha and O3 for the Owl Nebula there. And bottom right was LRGB, and then I shot ridiculously long hydrogen alpha to get the outer bloom of the ring nebula there. But it's mainly LRGB, and then I just rolled the hydrogen alpha into it.
So what is that?
Connie, what is this right here?
The Ring Nebula, that's another galaxy.
That's a galaxy right by M57. Yeah.
I didn't know that.
Yeah,
I didn't know that.
I thought it was like,
And this is the Veil Nebula
I've been doing it
that I
on
showed
there.
earlier.
oh my
I
goodness.
processed this for a client of mine, and he said I could use it. But this was hydrogen alpha, sulfur, and oxygen.
You have an idea how, possibly how long?
Yeah, this was, hold on, let me add it up. I've got all the files here on the computer, actually. It was
That's a hard one, man.
30 minutes for each channel, for each, or for subs, and he had 6, so it was probably total about 12, 15 hours.
15 hours?
But he had RGB and narrowband. So I used the RGB for all the color, which is why you've got the normal color without doing bicolor mapping or whatnot.
Right.
That's why you've got the reds and blues versus the whole palette coloring, and actually have some star colors here as well, as opposed to the magenta or the, whatnot. I think that's it. So, anything you want me to go
Very good.
back to?
Yeah.
Back to the, green.
Yeah.
M57 though, and honey, that's really cool. I mean, to be able to pick up.
It was right after I had my CPC fixed, brought in, so it was doing really well, and so I don't image off of it. I normally use it for basically my mount, my tracking, but the smaller planetary nebulas I'll use for it. So.
Connie, can you tell us again which scope you used for each of these pictures?
Yeah, the M81 was my Orion Eon 80 millimeter, and the other two were both the CPC 800 Celestron C8.
Which you're able to expose, what is the maximum left you with your,
I've done hours. I've done 90 minutes, but I had too many satellites go through. I chucked it.
so an hour though, you can
yeah,
routinely
I'll
do
do
with
an
the
hour
CPC?
once I, get the polar alignment down and whatnot. Yeah, I'll do an hour. Most of them I'll stick. It also depends on. I mean, I had dark skies in England. I didn't have a whole lot of light in the summertime, or dark in the summertime because it was light all the time.
Right.
But so I set my scope out in the back garden and left it there all summer, and then 2 a.m. to 3 a.m. every day I'd go out. But yeah, once I got the polar alignment,
So what is your guide, the guide scope you're using on the CPC 800?
I'll use the Eon.
You'll use the Eon?
Yeah.
Which is
I'll-
80 millimeter?
Pardon?
80 millimeter?
yeah.
Okay.
On the Eon, I have an off-axis guider, so I use it for it as well. But I'll generally use the Eon for.
And you've had good luck with the off-axis guide?
Yeah.
Okay.
Do you reduce?
I don't have a normal setup from what anyone has, so I wouldn't go by my setup for anybody else.
Most of what I did was the 10-inch LX200R with the 80 millimeter Orion. I'd either do wide field with the 80 and guide with the LX200 or reverse it.
I used to use the CPC to guide until I got the off-axis guider.
Yeah.
Doing some things, I just had so hard a time finding a guide star with it,
Yeah.
that's why I went with the off-axis when I was shooting with the Eon.
And you're using a Lodestar,
I am.
so that opens up a little bit more possibilities in terms. Now, I thought in one image I saw, it looked like you were using your CPC 800 as the guide scope and your Eon as the image scope. Is
I
that
have, yeah, I used to use the CPC to guide for the Eon.
for the
So I
Eon?
got the
So that's
off-axis.
that's amazing. Yeah.
I mean, the big issue with that is flexion.
It is, yeah.
And mirror shift. I mean, that's one thing I loved about the LX200R. It's got that lock, and it really works.
I
It'll
really
lock
haven't
the
had
mirror
much
down.
issues with flexion with my setup, so I've been lucky with my completely weird setup that no one else would dare try, that it works for me, so I've stuck with it, so.
I mean, I gotta admit, some of the stuff Mike did with the 200 millimeter, I'm sorry. Go ahead.
I was just wondering if you can tell the difference between reflected light as opposed to emitted light by a phase shift, or can you not decipher phase shifts in the wavelengths?
Yeah, the reflected light's gonna be wider.
Oh,
Yeah, it's gonna be a wider spectrum.
It's evening polarization, or, because the reflected light will be polarized versus emitted light.
Yeah.
It doesn't have a net polarization, but you need some pretty expensive equipment to measure polarization.
Yeah.
I don't think we probably use that. That's what we use a professional laser.
Did you use the same CCD on both scopes?
Yes. I have used my DSLR occasionally on both, but yeah, I generally bounce my attic between the two, depending on what I'm imaging.
And this is an ATIC 318.
314,
I'm
yeah.
so sorry, 314.
Yeah, it's a very small chip. I'm trying to think if, yeah, I think all these were with the attic.
Mhm.
There are some guys on several forums that were collaborating, and they would take their CCD camera and do a panorama, and then the guy would take the DSLR and get the color.
Like,
They
let me
would
go back to the beginning here.
mix together.
The North American Nebula, this one here, this was an 18 panel mosaic I did in England, an hour a night all summer long. And I did that with the hydrogen alpha, is I shot all 18 panels with it, and then did wider with the attic still, but on the wider field,
Right.
with
With the color.
a camera lens, for the O3 and the S2. And this was like 72 hours of exposure between the 18 panels. But yeah, it's basically the same thing, I just use a camera lens in the attic, for the S2 and the O3 to get the color, instead of using the hydrogen alpha for all the detail.
So I imagine just the H alpha by itself has 18 panels. Because it's such a huge thing, you probably wouldn't see noise as badly. You know, you said you only did 1 hour for each panel,
Yeah,
right?
well, no, it's 1 hour a night for 3 months,
Oh,
all
okay.
summer, because that was the only dark I had.
Because how many hours do you get when you're over in the UK?
In
To actually
the summer,
capture?
it's about an hour that I could use at a night.
Right.
In the winter, I get all night long.
Right.
I mean, I can go out at 4 p.m. and start imaging.
So when you use your camera to do the wide field, you mounted that, I bet you, on your CPC 800 and use that to guide, and then just captured with the
Mhm.
piggybacked on
I don't
the...
remember which, I think I used a 100mm lens or 50mm lens, I'm not sure off the top of my
Mhm.
head. I'd have to
What
go back
brand?
and check my Nikon,
Oh, of course.
and attach it to my, my attic.
Mhm.
And I've got a thing that I could roll in the filter too,
Mhm.
so. It's kind of my first try using that equipment setup too.
What kind of manipulations to the histogram do you use when you go from the 80mm to an 8" with, let's say, the same data or different data? Do you go in there and adjust?
I won't normally use both for the same, like, object. Very rarely will I roll both scopes into the same object unless I just want to focus on a specific area. That's what you're saying. I mean, I use both to image, but not necessarily on the same target, so.
One of the issues that I've run across in Narrowband is when you move from, with the same CCD, you move from one OTA to another of different focal lengths, and it varies greatly with focal length. You'll actually shift your wavelength. That's what happens. So when I'm on a project right now, we're combining Narrowband data from different speed scopes. We're having that problem because that's what happens. The bandpass for these narrowband filters is plus or minus,
Right.
centered around a particular wavelength. And when you use a really fast scope, for example, you really need a broader bandwidth because you've shifted that target wavelength you're now imaging. It's an effect of going with a faster scope.
Yeah.
We're having a heck of a time.
Yeah, like I
combining
said,
data.
since I haven't bounced the two very often for, I mean, I have for a few things, like I did for the trapezium for M42, and I combined that actually with DSLR, but for the most part, I haven't done that much, so I can't speak intelligently too.
Are you shooting close to f2.8 or?
Yeah, well, we got people with Hyperstar trying to
Right.
send us
Oh,
the
yeah.
overlay. Well, that stuff, that's a problem.
Yeah.
Well, that angle incidence
Just-
sort of undermines the whole concept of how the
Right.
filters work, right?
Right.
Just when it
Spread
hits
it
the
out.
filter.
And Astrodyne had
bounces off.
a deal of time with that for a long time, so they had that, get that figured out. So
Yeah, we're
just
living
try-
the
try-
nightmare because some of that Hyperstar, actually some guys got F2 dots they're submitting data on. Some of that data is really, really good, but it's so broad.
Yeah.
It's got other problems. So one of the things we learned was you need to stay within a particular focal length ratio zone when you're sharing data. It just makes it easier to process. But even in our own inventory, those of us that image, we have F2, F5, F10. Sometimes we image at F30 or 40 for planets. So that's a problem. And so you can't always necessarily easily combine that data. You just can't.
Yeah.
We have to figure out how to do it.
Anything else?
Just a generic question on
You're-
O3 filters.
No, you're looking through.
Uh,
No, you're
Are
looking
those,
through the
so the O3 filters that you use for narrowband imaging or even regular imaging, are they the same as what you use visually?
I don't do much visual, so I can't speak to that.
The visuals are wider.
Visuals are wider?
Yeah.
Sorry, I don't visual filters.
Here
so-
again, you gotta let enough light through for your eye to react to it. There are filters you can buy to put on lenses to enhance.
Yeah,
I mean,
just
I
haven't-
guess that's
haven't
what
done
everybody
much-
uses to see
I do
the
much of
horse
that.
head.
I know they exist, but I
Yeah.
can't speak to, the
Well, I think it's
comparisons.
listed cost, right? And they
Yeah.
nail it in there.
Oh, sure.
I
Yeah,
know
oh,
people
yeah,
buy those all right, because it's so filtered.
yeah,
It'd be pretty expensive.
yeah.
Ani, do you have any future projects that that you're shooting for in terms of your work?
I haven't really,
Have you had a clear night yet?
the problem is I can't shoot from my yard either because I have very narrow width between my 100-foot pine trees.
Oh.
And that basically runs north-south, so I can't get any east-west doing
When I
anything.
moved in, my pine trees let me see the North Star, and I walked out there this spring and looked up.
I have a
trees
lovely
have grown about
north-south
8
view,
feet.
and that is it.
Yeah,
So that's why I'm really looking forward
But
to
Steve,
Stockton
I
River,
told her-
because I'll
I
actually
told-
be able to get out and image them.
I told Ani she's only 20 minutes from Howell Woods, from her house.
oh, wow, yeah. Howell Woods isn't
20
too
minutes.
bad.
20 minutes.
It's a whole lot better than Big Woods.
Yeah, because I'm over Clayton, or past Clayton, so.
That's good.
Okay. Yeah, it's not too bad.
Yeah, so I haven't really looked, and I gotta come up with a list of targets I wanna shoot for Stockton River, so I'll be out there all week.
Yeah.
We're going to try to do the Messier Marathon next,
Oh, yeah.
Yeah, we do.
It might be
it
hard to
every year.
do with your,
I think what
I wanna
Brian.
shoot the
Brian
Crab Nebula at
was
some
doing
point. I
that.
haven't done that since I first started imaging, and that was just awful, because that was like the first thing I tried. So I won't actually do a decent one of that.
Yeah, I can't get into that. I just,
I have a feeling all this bad weather's going to clear up and we're going to have open skies for 2 months.
that's pretty good.
Hope so. Be nice.
Yeah, we're trying to do a fall Messier marathon.
Look to Hanging Rock, you can get them all.
108. I think you can do all of
You
them.
can carry your scope up there.
Anything else or any other slides you guys want me to go back to? Or?
Very good.